Okay, so today we are looking at simplifying expressions, and we want to be able to simplify an algebraic expression by combining like terms. Like terms is something we need to understand really, really well. I'm going to try to do my best to draw some pictures. And today I want you to have two colors so we can really clearly know what we're doing here. My two colors are red and green today, looking very Christmassy. Whatever two colors you have would be lovely, okay? So here I have an algebraic expression. This is an example of an algebraic expression. It is simply a collection of numbers like 14 and 9, letters like x's and y's, and operations, addition, subtraction, and we have some multiplying going on in here, 14 times x, -2 times x. So we have a collection of numbers and letters and operations, and that makes up an algebraic expression. So what we want to be able to do is identify all the different terms. You can see this word terms here. In this expression, there are 1, 2, 3, 4, 5, 6 terms. A term are things that are separated with addition and subtraction, okay? So it's important to be able to count them up. They can be very useful to be able to count all the individual terms. Do you see 6? I've got this one here, and then the 9, and then the -2x, and the 8, and the -5x, and the 1. There's 6 of those terms. Okay, so some of them are called variable terms. Variable terms are terms with a variable. The variable might be x or y or p or q. They're the letters. So if the term has a letter attached to it, then it is called a variable term. So looking in this example, what is one of the variable terms? Yeah, will you circle that? And what I want you to do is use one of your colors and circle that 14x or highlight that 14x. Now, I want you to always be thinking, because this is going to just make things so much easier, this 14x, is it a positive 14x or is it a negative 14x? It's positive. We look to the sign to the left, and if nothing is there, like this, there's nothing to the left of it, it's positive then. So we're going to always keep a sign attached, okay? And that's kind of important. All right, what's another variable term? Okay, so is it a 2x or is it a -2x? Negative. So again, circle the -2x because I want you to take the sign along for the ride. So a -2x. We want to include the sign to the left. All right, what's the last variable term? Is it a 5x or a -5x? -5x. Circle that -5x. And again, that sign, we no longer are going to think about things as addition or subtraction. It's really positive or negative, okay? -5x is the last variable term. Constant terms are the terms without a variable. They are just a constant plain old number, okay? A plain old integer or a plain old rational number. So what is one of our constant terms? 1. A positive 1. Yep, and we can just write a 1. Perfect. I'm going to use a different color for that one. What's another constant term? 8. Yeah, and again, I want to include the sign. It's a positive 8. So I can write the positive if I want or just leave it off. That's fine. And the last one? The 9. A positive 9 is our last constant term there. Very, very good. Now, so our variable term, the coefficients are the number next to the variable, the number that is connected by multiplication. So our coefficients are the numbers in front. So what are our numbers in front? What are our coefficients here? 14 is a coefficient. What else is a coefficient? With a sign? Negative 2 is the coefficient. And what's the other coefficient? Negative 5. So it's just the numbers in front, okay? Those are the coefficients. They're very, very useful. All right, so we want to be able to identify the variable term, the constant, and the coefficients here. So in number 1, what are our variable terms? Yeah, we have an 11a, and we also have the 4a. Very good. Do we have any constant terms in this expression on number 1? Are there any constants? No, there aren't any constants. What are our coefficients? The coordinating number. 11 and 4. The coefficients are the numbers in front of the letters. So that's pretty easy. Let's look at number 2 here. What are our variable terms? Yeah, 3x. 3x and that positive 7x. Very good. What are our constant terms? 6, a positive 6. Very good. And a negative 4 are our constant terms. There you can see how I'm using different colors just like above. What are our coefficients? 3 and 7. Coefficients are the coordinating number in front of the variable. Great. What did I do with my paper? Oh well. I have no idea where I put my answer key. All right. Number 3. What are our variable terms? Negative 12m. Very good. I love how you included the negative there. And positive 4m. I love how you're saying the signs first. Oh, I wrote an X. I should be writing an M. Silly me. All right. Negative 12m and positive 4m. Very good. What are our constants? Good. Lovely, lovely. Negative 3 and positive 16. I love how you're talking about the signs. That is fantastic. What are our coefficients? Almost. Negative 12 and a positive 4. Coefficients. Make sure you include the sign. Take it along for the ride. Ooh, this is an interesting one. Number 4. What are our variable terms? 6k and k, you know what? That's very good. 6k and positive k. Very interesting. Okay. What are our constant terms? Negative 4 and a negative 2. Very good. We have a negative 4 and a negative 2. I love how you're taking the sign along for the ride. Very good. Now, tricky. What are the coefficients? 6 and 1. Very, very good. 6 and 1. There is always a number in front of our letter. And what it's saying is there's 1K here. We've got one of them. All right? And with or without that extra little 1, we know we've got at least that one. Okay? So what we want to be able to do now that we can identify all these parts is make sure that we can combine like terms. And one way that I was thinking I could do this, but I didn't have time, I'd like to use marshmallows that are different shapes, like Lucky Charms. That's what I was thinking. But I didn't have time. So, we're going to pretend, and we're going to draw it. So algebraic expressions, we want to really understand what they are when we are combining like terms. So I'm going to say I'm going to let my letter X represent that red balloon. You know the red balloon in the Lucky Charms box? We're going to pretend this is that red balloon, okay? So our red Lucky Charms balloon, we're going to call that an X. And if I have, what's another thing from the Lucky Charms? The rainbow? All right, I can kind of make a rainbow here. All right, so I'm going to say that my Y, letter Y, we're going to let it be that rainbow. So I'm just going to do a little rainbow here. And you can just make a rainbow. There's the red and the green and the blue little rainbow marshmallow. Cool, cool, cool. Okay, so there's my little Y. And then we just have like plain old, regular old, boring numbers. And I'm just going to do those in black. Okay. So if I have an expression, I can use these Lucky Charms marshmallows to represent it. So if I have the expression like 3x plus 4y minus 2 plus x plus y plus 5, okay? So here's this big, long expression. This is a big, long algebraic expression. And what I want to do is I'm just going to represent it using my little key here. And so I have 3x. What should I draw to represent my 3x's? What was x? 3 little red balloons. Okay? So I'm going to draw 3 little red balloons. So there's my one little red balloon marshmallow, and here's another red balloon marshmallow, and here's the third red balloon marshmallow. All right? That is how we would represent. We got 3 of them. 3 little red balloons. So how do I represent my 4 Ys? 4 rainbows. So I've got 1, 2, 3, 4 little rainbows. I'm going to do my little color coding here because this is totally fun. This makes math fun. And of course your rainbows don't have to be quite so detailed. There we go. So I got 4 rainbows. Now, here I've got plain old number. All right, this is -2. This is 2 negatives. So I'm just going to draw 2 negatives there because they're just 2 negatives. What do I draw for an X? A balloon. Yeah, it's really just one red balloon. So I'm going to draw my one red balloon. That one's kind of a crazy red balloon. There we go. There's my one red balloon. It looks kind of more like a lock key. Did you just fall asleep just now and just wake yourself up? That's funny. All right. What should I draw for my Y? A rainbow. My Y, I've got one wee little adorable little rainbow here. That's so fun. Okay, there's my little rainbows. I think the rainbows were my favorite marshmallows in the Lucky Charms. Aren't they yours? Don't they make you feel so happy? Okay. All right, and last but not least, here I have a +5. What am I going to do to represent +5? 5 positives. Yeah, 1, 2, 3, 4, 5 little positive signs. 5 little positive units, if you will. Now, when we combine like terms, can I put my red balloons and my rainbows together? Are they like terms? No, they're totally different things, so I cannot combine them. However, I do have my 3 red balloons that can be combined with the 1 red balloon to give me how many red balloons? 4 red balloons. And instead of drawing pictures, I think, can I just write 4 X's? Would that represent the same thing? Yeah, because instead of 4 red balloons, the X is just holding the place of my red balloon. Now, you get that? Okay. And now, so I want to look at my cute little rainbows here. And I have my rainbows. I got 4 little rainbows, and I got 1 more little rainbow. So how many rainbows do we have? We got 5 little rainbows. So how could I represent that? 5 what? Are they positive, happy little rainbows, or are they negative, lame little rainbows? They're +5 little happy rainbows. And so we would just write A5Y. Now, here's the tricky part. All my positives and negatives, they are at war with one another. Who wins? The positives win. By how many? 3. Very good. because the -2 and +2 are going to eliminate one another, and we're left with +3, okay? Ladies and gentlemen, when we combine like terms, all we have to do is combine the things that match. So if they have the same variable, then we get to combine the coefficients. So the 3 plus 1, 3x's plus 1x gives us our 4x's, all right? And the 4y's plus another y gives us 5y, little happy rainbows, okay? Does that make sense to you? Isn't drawing pictures in math so much fun? Yeah, I thought so. Okay. So here we go. You can simplify an algebraic expression by combining like terms. This means to combine common variables and constant terms. So to simplify the expression, and this is where our two colors are going to come in really handy here, I want you to use colors while we're doing these today, because it's really going to help you and me. So I'm going to take my lovely little variables and combine them. So if I have 14x, what else is that going to combine with? What's this? -2x. Very good. And then we also have a -5x. Oh boy. We have 14, you can think about it, 14 positive x's. How many negative x's do we have? 7 negatives. All right, so I've got 14 positive x's. I got 7 negative x's. Who's going to win? The positives are going to win by how many? 7. Positives win by 7. Very, very good. Now, let's look at our constants. What are our constants? +9, +8, and +1. All those are positives. How many positives do we have? 18. 9 and 8 makes 17, plus 1 more makes 18 positives. So we get a 7x plus an 18. Okay, very, very good, very good. Here, on number 11, we want to simplify each of these expressions. Are these like terms? Yeah, they both have an x. So I have a positive 4x and a positive 7x. How many do we have? 11. Positive 4 and a positive 7 makes a positive 11 x's. They combine. 4 plus 7 is 11. All right, tricky 12. They are like terms. They both have. What's the coefficient here in front of the k? A 1. There's always 1. We've got one little rainbow, okay, to represent that k. All right, so now I have a positive 1k and I have a negative 6k. They go to war. Who's going to win, positives or negatives? Negatives are going to win by how many? 5. So we have a negative 5k. Again, you can think about it like a positive 1 and 6 negatives. A positive and negative go to war and cancel each other out, and so we're left with 5 negatives. This is where you get good at adding integers, okay? All right, number 13. Which are the like terms? 6c and 11c. All right, they're both positive, so that gives us how many c's? 17 c's. Very good. And what's our constant term? A positive 1. They don't have any friends to combine with, so it just gets added on to the end. Can I add together the 17c and the 1 and make it 18c? Yes? No. Again, the C tells us what shape the thing is, okay? So the C maybe is that shamrock, right? It's that shamrock in the Lucky Charms box. I got 17 shamrocks, and here I just have one positive. They're not the same thing, so they can't be combined. Okay, does that make sense to you? All right, we really want it to make sense. All right, let's look again. Let's skip down here to number 17. All right, number 17. What are our like terms, our variable terms here? Very good. I love how you inserted the -1 in there. Very good. So we have 9 V's, we've got a -3 V's, and we've got a -1 V. And if you think about it, maybe I could do like, I don't want to write it all out. I've got +9 of them. How many negatives do we have? We got 4 of those negative V's. All right, so we got 9V and -4V. Who's going to win, positives or negatives? Positives are going to win by how many? 5, yeah. So we've got 5 V's to win there. And we have a +7 that's just hanging out. Let's look at 18. My variable terms are... Good, -2n and -3n. I've got a bunch of negatives here. How many negatives are they? Yeah, we got 2 negatives and 3 negatives. That's going to make 5 negative n's. Now, constants. My constants are +4 and -19. +4, -19. Who's going to win? The negatives are going to win. The negatives are going to win by how many? By 15. All right, we got a whole lot of negatives. They're definitely going to win that battle. All right. Let's look at number 19. What are our variable terms here? Okay, we've got -14W, a +10W, and a +2W. We've got 14 negatives here. We've got 12 positives. So 14 negatives and 12 positives. Who's going to win? The negatives are going to win by how many? By 2. So -2W. And our constant term is that -11 is just going to tack on the end there. Let's look at number 20. My variable terms are good, -5R and +13Rs. -5R, +13R. Who's going to win here? The positives are going to win. By how many? By 8. Very good. +8R. That's going to win that battle. And then our constants. We have a -1 and a -6. That's a whole lot of negatives. Do they go to war? No, they join forces. They get stronger. So how many negatives are there? There's 7 negatives now. They have combined forces. Okay. Give me a thumb. How are we doing? Awesome. Okay, let's do one big one here. Or maybe 2. We're going to do 2 more. We're going to do 24 and 26, okay? 24 and 26. Here we go, ladies and gentlemen. Careful now. On number 24, I've got a bunch of different letters going on here. So let's start with the things with A's. What are our A variable terms? There it is, the last one, -3A. We have a -1A and we have a -3A. Did they go to war? No, they do not. They are friendlies. They are on the same team. How many of them are there now? -4. Very good. A -1 and a -3 combined give us -4. All right, what are the other terms that we can put in there? Good. -5B, +4B, and -11B. All right, let's look at those negatives and positives. I only have 4 positive B's, but I have how many negative B's? Negative 16. Negative 16 B's. So let's see. Negative 16B and a positive 4B. All right, who's going to win? The negatives. We got a whole lot more negatives here. We got 16 of those negative B's. All right, and then how many are they going to win by? 12. Negative 12B. Very good. And what's our very last thing? Plus 2. Just that plus 2. Didn't have anything to combine them with. Very good. All right. Actually, I like 25 better. Let's do 25. Number 25. 25. What's two things we can combine? 9M and 1M. Good. 9M and 1M. They're friendlies. They're both positive. They're on the same team. So how many M's do we have? 10. Positive 10 M's. Very good. What are some more friendlies? Good. Negative 5N and negative 2N. That's a whole lot of negatives. How many negatives we got there? We got 7 negatives. Negative 7N's. Very, very good. And then last, we got some other friendlies here. Yeah, positive 14 and negative 7. We got 14 positives. We got 7 negatives. Who's going to win that battle? Positives are going to win by 7. Very good. All right, ladies and gentlemen, do you have questions for me? Are you good to go? All right, super fab. All right. There. That's the one I wanted. Right there. Oh, too far. Come back. Come back. There we go. Okay. All right.